this example. So let's look at combining rational trig expressions. They want us to simplify this right here. And you could use the trig identities to start rewriting some of these, but it may not take you anywhere in terms of simplifying or canceling out expressions. So just be careful on this one, since there is an addition of fractions, or rational expressions, I guess. Rational, fancy word for, fractional component, fraction that has expressions. Let's go ahead and combine these, and in order to do so, if you recall, combining requires finding the least common denominator. And in some cases, without repetition, the easiest way is to multiply out the factors in the denominator, again without repetition. So the least common denominator would be just this denominator times this denominator. So you rewrite your fractions, and I'm going to go ahead and show this right here. I have this fraction right here, sine of theta over 1 plus cosine of theta. Now it does require this denominator, that 1 plus cosine of theta times sine of theta. So I look at the denominator that I have right now, and I notice that it's missing a times sine of theta. So I needed to add that, and so that I don't change this expression, I have to also multiply it by sine of theta. And the reason, again, it's sine of theta over sine of theta is so that the denominator match the one that I wanted. Right now I'm going to take the same thing, do it to this problem. Cosine of theta over sine of theta. What is this missing? Well, the 1 plus cosine. So I have to put 1 plus cosine of theta, so that again, when I multiply sine times this, it gives me that denominator. And whatever I do to one side, I have to do to, well, I guess not one side, but whatever I do to the denominator, I have to do to the numerator, so that it doesn't change my problem. If you notice them, I color-coded them for a reason. The blue portion is the original expression. What I added in red should not change my problem. And if you do that, sine divided by sine is equivalent to 1. When I multiply an expression by 1, it doesn't change the problem. But the reason I wanted to do this was so that the denominators are the same. And I guess let's simplify this a little bit more. The numerator here is sine squared of theta over this denominator. This expression right here, I'm going to distribute that cosine. So it's going to be cosine of theta times 1 is cosine of theta plus cosine squared of theta. And again, all of this is over the same denominator. Now, when you combine these right here, they have to have, like I said, the same denominator for me to add up the numerators. Keep the denominator the same and combine the numerators. Sine squared of theta plus cosine of theta plus this cosine squared of theta. Now on this one, it may, like I said, it may require a little bit of practice in recognizing some of these Pythagorean identities. Remember, whenever you see this cosine squared, sine squared, you might want to think of your Pythagorean identities. And the first one I should be familiar with is this one, because from this I could derive all the other ones. Good, so then this right here, right, good. So all of this right here is equivalent to 1. So I'm going to replace that and say 1. I still have that plus cosine of theta, and on the denominator I have this right here times sine of theta. And now you should also notice that these are going to cancel each other out. 1 plus cosine of theta, and I'll be left with, still I have 1 on the numerator over sine of theta, and this is equivalent to cosecant theta.